We are not familiar with gravity A. It is a small gravity wave which is the major contributory force that holds together the mass that makes up all protons and neutrons. Gravity A is what is currently being labeled as the strong nuclear force in mainstream physics, and gravity A is the wave that you need to access and amplify to enable you to cause space-time distortion for interstellar travel. Locating gravity A is no problem because it is found in the nucleus of every atom of all matter here on Earth, and all matter anywhere else in our universe. However, accessing gravity A with the naturally occurring elements found on Earth is a big problem. Actually, I'm not aware of any way of accessing the gravity A wave using any Earth elements. To keep them straight, just remember that gravity A works on an atomic scale, and gravity B is a big gravity wave that works on a stellar or planetary level. However, don't mistake the size of these waves for their strength, because gravity A is a much stronger force than gravity B. You can momentarily break the gravity B field of the Earth simply by jumping in the air. So this is not an intense gravitational field. However, the Earth is not representative of all matter within our universe. The residual matter which remains after the creation of a solar system is totally dependent on the contributing factors which were present during the creation of the solar system. This is true whether you believe that the origin of the universe was an evolutionary event or that a supreme being caused this event to happen. The two main factors which determine what residual matter remains after the creation of the solar system are the amount of electromagnetic energy and the amount of mass present during the solar system's creation. But experiments in the lab for heavy ion research in Germany have shown that this may only be true up to a certain point, as the half-life for element 109 is longer than that of element 108. The point is that our observations and theories are accurate. The fact is that heavier stable elements with higher atomic numbers which have more protons, neutrons, and electrons than any Earth elements do exist. However, up until this point in history, there has been no physical evidence to prove this. But now that proof is here. The most important attribute of these heavier stable elements is that the gravity A wave is so abundant that it actually extends past the perimeter of the atom. These heavier stable elements literally have their own gravity A field around them, in addition to the gravity B field that is native to all elements. No naturally occurring atoms on Earth have enough protons and neutrons for the cumulative gravity A wave to extend past the perimeter of the atom so you can access it. Even though the distance that the gravity A wave extends is infinitesimal, it is accessible, and it has amplitude, wavelength, and frequency just like any other wave in the electromagnetic spectrum. Once you can access the gravity A wave, you can amplify it just like we amplify any other electromagnetic wave. To demonstrate how a wave is amplified, we can use this oscilloscope, and as you can see, it graphically depicts the tone you hear as a wave. As we amplify the tone, you can see that the size or the amplitude of the wave increases, giving us a more powerful version of the same identical wave, and thus the tone sounds louder. In like manner, the gravity A wave is amplified and then focused on the desired destination to cause the space-time distortion required for space travel. This amplified gravity A wave is so powerful that the only naturally occurring source of gravity that can cause space-time to distort this much would be a black hole. Our solar system has one star, which is our sun, but the majority of solar systems in our Milky Way galaxy are binary and multiple star systems. In fact, many single-star systems have stars that are so large that our sun would appear to be a dwarf by comparison. Keeping all this in mind, it should be obvious that a large single-star system, binary star system, or multiple star system would have had more of the prerequisite mass and electromagnetic energy present during their creation. This makes it possible for these systems to possess elements which are not native to the Earth. Scientists have long theorized that there are potential combinations of protons and neutrons which should provide stable elements with atomic numbers higher than any which appear in our periodic chart, though none of these heavy elements occur naturally on Earth. 88 of the first 92 elements on the periodic chart occur naturally on Earth. Some heavier elements do occur in trace amounts, but for the most part, we synthesize these heavier elements in laboratories. Generally speaking, the stability of these synthesized heavy elements decreases as their atomic number increases. So back to our original question. What is the power source that provides the power required for this type of travel? The power source is a reactor, which uses element 115 as a fuel, and uses a full annihilation reaction to provide the heat which it converts to energy. making it a compact, lightweight, efficient onboard power source. I've got a couple of quick comments about element 115 for those of you who are interested. By virtue of the way it's used in the reactor, it depletes very slowly, and only 223 grams of 115, which is just under half a pound, can be utilized for a period of 20 to 30 years. Element 115's melting point is 1740 degrees Celsius. So we've learned how space-time is distorted by a gravitational field, we've learned how that gravitational field is generated, and we've also learned where you get the power to accomplish all of this.